Everyone, welcome to our new video. In this video we will continue with the continuous random variables and see some basic applications of various R functions. In the last video I talked about discrete distributions and random variables. Now let's continue with the continuous random variables, and one of the most commonly used distributions is the uniform distribution. So you can check the uniform function, and it will show you the documentation here, and you can see that we have the uniform distribution. We can evaluate the density function for this continuous random variable. We can also evaluate the cumulative distribution with this P uniform. We have the quantiles can be calculated. Remember, quantiles meaning we are actually inverting the distribution and going from the y domain to the x-axis, and then we can also generate some random numbers from a given uniform distribution. So these are, again, the syntax of these functions are similar as the other distributions such as binomial, Poisson, etc., and normal distribution as well. Here are some examples. For example, you want to evaluate x equals to 1, the probability x equals to 1 for the uniform random variable defined from minus 0.4 to 1.1. So you need to define this domain for your uniform, but the default values are 0 to 1. Okay, by default it is 0 to 1. And basically if you run this line here, you get the probability as 0.66 repeated. That's because in the uniform density function we have 1 over the length of this interval, the domain you defined here. So the length is 1.1 minus 0.04. So this gives you 1 over 1.5. So actually if you write 1 divided by 1.5, you see this is the probability here for the density function. And you can also evaluate multiple probabilities at once. I mean, by setting this x as a vector of values, and if I run this line, you see that I get some 0. That's because I evaluated my uniform distribution at x equals to minus 2. That is out of the range for x. Okay, so if something is out of our domain, the probability will be equal to 0 naturally. And you can, change these values. You can have a random variable from 0.01 to 0.41, and then again evaluate some x values. Okay, and you see the uniform distribution. Within the domain we have the same probability density for each of these x values. Another example, now if you want to calculate the cumulative probabilities, so suppose I want x less than or equal to 0.02, and suppose this is the minimum and maximum range for this uniform random variable, then you will use the P uniform and input this threshold that you want to calculate for your cumulative distribution, and you see this is given by 0.13, this 3 repeated. If you want to calculate the probability that x is greater than this number, then you can represent this as actually 1 minus the probability x is less than or equal to minus 0.2. Okay, and we know how to calculate this guy using this function here. The only thing we need to do is now 1 minus this number. That will give us the probability x is greater than minus 0.2. Okay, so this is how you calculate the different probabilities in the uniform distribution. And you can have another uniform random variable, but with a different domain, okay? Then you need to just change this. And you can evaluate that. Alternatively, in some cases, you want to calculate the probability that x is within an interval. So for this one, you are going to write this as the probability x less than 0.6 minus probability x is less than 0.2. Okay. So these now are equivalent, and you will calculate first this probability using our function here, and then subtract the remaining one. This difference gives you the probability of x being in this interval. Okay. And again, the domain is up to you. I mean, how you want to have this domain defined. You can change this minimum and maximum. Regarding the quantiles, again, we can use the quantile function with the uniform distribution. Remember, the quantiles are giving, we give them the probability, and quantile function returns us the value from the x domain. So, for example, here, for the uniform random variable between 0 and 1, the mean, the center, is given at 0.5. If you change this to if you change the domain from -1 to 1 and check again the center by evaluating probability equals 0.5, that corresponds to the center of the distribution, you see the center is now 0 because our domain is from -1 to 1. Okay, since uniform is also symmetric distribution, the center will be just in the midpoint. Okay, and you can, of course, change this number, let's say, to 2 or let's say 3, and then you see now the center is at 1. Okay, so you can evaluate different domains and check the center of the distribution using the quantile. Alternatively, you can work with the 25 percentile, I mean the quantile value, and suppose we are defining our uniform from -1 to 1, and then if I run it, I will see that basic 0.05 corresponds to the 25 quantile. Or one more example, if we want the domain from 0 to 1 and evaluate the 25% quantile, again you see 0.25. Finally, we can generate some uniform numbers from the R uniform function. And again, you need to define the domain for your uniform random variable, and you need to input how many random numbers you want R to generate. So, for example, I generated 10 values, or we can change this to, let's say, 20. So I will generate 20 random numbers from -5 to 5. These are uniform random numbers, of course. And you see we get these random numbers. If we don't enter the min and max, then the default is within the 0-1 range. And you see if I run, it gives me 10 uniform numbers from 0-1. And finally, here I'm just creating a simple plot by generating x and y coordinates from uniform random numbers 100 for each. So if I run, and then if you want to plot them together, and basically this will look like we are filling this unit square randomly by generating these x and y coordinates from 0-1. And you can, of course, increase this as much as you want. And in many applications, you will need to generate uniform random numbers. For example, for Monte Carlo simulations, especially, you will be generating many uniform random numbers. And you see we can fill this unit square more and more as we generate more uniform random numbers. Okay, so thank you for watching this video. In the next video, I will continue with other continuous distributions.